Hello and welcome to this sixth set of problem, that is problem number 51 to 60 of logarithm. And as always, I'll say that when I'm reading the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further delay, let's get started. Problem 51 says that solve log of 1 plus log of 1 plus log of 1 plus log of x is base p, and then we continue with outer base c and b and a is equal to 0. So here we remove this log a, so right hand side would be a to the power 0, that is 1. So this 1 gets cancelled, we are left with starting from log b, so we get this. Then again we remove log b, and this right hand side will be b to the power 0, that is 1. Again 1 gets cancelled, and similarly here c is removed, we are left with c to the power 0, that is 1. 1 gets cancelled, and we eventually find x is equal to p to the power 0, that is 1. Problem 52 says that solve log to the with base 7 of log with base 5 of square root of x plus 5 plus square root of x is equal to 0. So in this case, first we remove log 7, we take anti-log, and this becomes 7 to the power 0, that is 1. And then this we remove log of 5, we take anti-log, and then this becomes 5 to the power 1, that is 5. So what we are left with is square root of x plus 5 is equal to 5 minus square root of x. We square both sides, we get x plus 5 is equal to 25 plus x minus 10 square root of x. So x gets cancelled, we bring 10 root x to the left side, 5 to the right side, we get 25 minus 5 is 20, and then we divide 20 by 10, so we get square root of x is equal to 2. This square root sign is extended, it's a typing mistake. So we have square root of x is equal to 2, so x is equal to 4. Problem 53 says that solve log of x with base 2 plus log of x plus 2 with base 4 is equal to 2. In this case, we write 4 as 2 square, so when it comes out, it becomes half. Then we take LCM, we get 2 log of x with base 2 plus log of x plus 2 with base 2, and we multiply 2 with the right hand side, we get 4. So then we bring 2 inside, we get log of x square plus with base 2 plus log of x plus 2 with base 2. So x square into x plus 2 is equal to 16, which means x is equal to 2. Problem 54 says that solve log of x plus 1 by log x is equal to 2. So in this case, we multiply log x with 2, it becomes 2 log x, which is equal to log of x square, so x plus 1 is equal to x square. That means x is equal to 1 plus minus square, there should be a square root here, 1 plus minus square root of 5 by 2. But x has to be greater than 0, because in the denominator we have log x. If x is not greater than 0, then it will be a complex quantity, but we are dealing with real numbers. So since x is greater than 0, x is equal to 1 plus square root of 5 by 2. Problem 55 says that solve 2 of 2 multiplied with log of a with base x plus log of a with base x plus 3 into log of a with base a square x, where a is greater than 0. So in this case, we take all these in the, rather I'll say that we exchange the number and the base, and we bring all these to denominator, the logarithm to denominator. So it becomes 2 by log of x with base a plus 1 by log of x with base a plus 3 by log of a square x with base a is equal to 0. So then we expand this, we get 2 by log of x with base a plus 1 by x becomes log of a plus log of x with base a, and a square x becomes log of a square with base a plus log of x with base a, and 3 remains in numerator. So then we write log of a with base a as 1, and here it will become 2. So we have this. Then we let log of x with base a is equal to z. We get this equation, which is equal to, upon LCM, 6z square plus 11z plus 4 is equal to 0. We get two values of z, minus half and minus 4 by 3, when we solve this quadratic equation. So x is equal to 1 by square root of a, comma 1 by cube root of a to the power 4. Problem 55 says that solve x plus log of 1 plus 2 to the power x with base 10 is equal to x log of 5 with base 10 plus log of 6 with base 10. So in this case, we multiply x with 1, that is log of 10 with base 10. So when you will have that, it will become the power of that. That is, it will be equal to log of 10 to the power x with base 10. That is equal to x, because x will come out, log of 10 will become 1. The second term remains same on the left hand side, and right hand side remains same. So then we multiply, left hand side becomes 10 to the power x into 1 plus 2 to the power x, and right hand side we multiply, it becomes 5 to the power x into 6. So you see both sides are having log of base 10, so you can take anti-log and the numbers will be equal. Then I divide 5 to the power x with 10 to the power x with 5 to the power x, we get 2 to the power x here, and then the other term in the product remains same, that is 1 plus 2 to the power x, and 6 is written as 2 into 3. So from this we can solve for 2x, that is 2x will be 2 and 1 plus 2 to the power x will be 3, so x is equal to 1. Problem 57 says that solve x to the power 3 by 4 log of x by 2 whole square plus log of x with base 2 minus 5 by 4 is equal to square root of 2. So in this case we take log with base 2 of both sides. So the power comes out here, which is equal to 3 by 4 into log of x with base 2 whole square plus log x with base 2 minus 5 by 4 multiplied with log of x with base 2 is equal to, the right hand side will become 1 by 2 log of 2 with base 2. So again we take log z is equal to log of x with base 2, we get a cubic equation, in this case 3 by 4 z square plus z minus 5 by 4 into z is equal to 1 by 2, and then you can solve the cubic equation to get 3 roots for z, and that will give 3 values of x, which will be equal to 2 comma 1 by 4 comma 1 by cube root of 2. Problem 58 says that solve x square plus 6 to the power log of x with base 3 is equal to 5x whole to the power log of x with base 3. So in this case log 3x has a possible value of 0. In this case x will be equal to 1. However, if log of x with base 3 is not equal to 0, this shouldn't be 1. If this is not equal to 0, then we can write x square plus 6 is equal to 5x, that is x is equal to 2 and 3. Problem 59 says that 3 plus 2 square root of 2 whole to the power x square minus 6x plus 9 plus 3 minus 2 square root of 2 whole to the power x square minus 6x plus 9 is equal to 6. So in this case, we observe that 3 plus 2 square root of 2 is equal to 1 by 3 minus 2 square root of 2. So we rewrite the given equation as 3 plus 2 square root of 2 to the power x square minus 6x plus 9. And the second term, we also make that 3 plus 2 square root of 2. And the power will be negative in this case of the previous value, that is minus x square minus 6x plus 9 is equal to 6. Now we let z is equal to 3 plus 2 square root of 2 x square minus 6x plus 9. So z plus 1 by z is equal to 6. And we get two values for z, 3 plus minus 2 square root of 2. So once we have this z, we can find out x. And x will be 2 and 4 if you substitute for this, because the roots will be irrational. Problem 60 says that we have to solve the equation log of 8 by x square with base 8 divided by log x with base 8 whole square is equal to 3. So in this case, we take the denominator to the right hand side. Right hand side becomes 3 into log of x with base 8 whole square, and left hand side we expand. It becomes log of 8 with base 8 minus log of x square with base 8. So this becomes 1 minus 2 log of x with base 8 is equal to 3 log of x with base 8 whole square. Now we let z is equal to log of x with base 8. We get the quadratic equation 1 minus 2z is equal to 3z square, which we solve to get z is equal to minus 1 comma 1 by 3. So x is 2 and 1 by 8. So with this we come to the end of 6th set of the problems, and I hope that you are enjoying this series of videos. and find it useful. If so, then please subscribe to the channel and like the video, because that will motivate me, as well as it will help the video reach more students so more people can benefit from it. And if you have a comment or a suggestion, or you want to ask something, then please make use of the comment box. Thanks a lot for watching. Enjoy.